Good morning, my dear students. So today in these sessions, we are going to discuss regarding the conic section. Okay. So we know that the conic section is a curve formed by the intersection of a plane and double nap cone is called as conic section. Let us see. This is one cone and one more cone will be mounted at the tip of the cone is called as double nap cone. Okay, let us see the topmost or intersection point of the cone is called as what we can say as apex. Clear? Then this line, right side line or left side line, so this line is called as generator line, and the bottom of the cone is known as base of a circle. The center line is called as altitude or axis of the cone. So I will explain one by one. Let us see. I will elaborate this figure here. Then you can understand very easily. Let us see. This topmost part of the cone is known as apex. What we can say? Apex. The topmost part of the cone is known as apex. The joining, the bottommost, this bottommost part of the cone is known as base of a circle. Clear? The joining from topmost point from apex to base of a circle toward left hand side, toward right hand side, this line is called as slant edge. Okay, and then the center line or axis line is called as altitude line. This line is called as altitude, or we can say as axis of a base circle. Clear? The all inside line of a cone is called as generator lines. Clear? This all inside lines is called as generator line. If you cut the cone, then we will get the different shape. Like we will get the shape of ellipse, we will get the shape of parabola, we will get the shape of hyperbola. Meanwhile, we will get the shape of circle. Clear? Then, so I will write here. First one is circle. Second one is the ellipse. Third one is the parabola. and fourth one is the hyperbola. Hyperbola, right? First, I will discuss regarding the circle. How to cut this cone to get the circle. I will recall this one. The topmost part of the cone is known as apex. The bottommost part of the cone is known as base of a circle. The left hand side and the right hand side of the cone is known as slant edge, and the center line of the cone is called as altitude or axis of the line. The all inside multiple lines is called as generator lines. Clear? Then if you cut the cone, then how we will get the shape of circle, shape of ellipse, shape of parabola, shape of hyperbola? Let us see. First pick the heading circle. Then so please tell me how we will get the circle, dear. We know that the circle we will get if you cut the cone in such a way that this cutting cone should be parallel to whom, dear? Should be parallel to base, because the base should be looking like a house. It should be looking like a circle. So we can say that this cutting plane should be parallel to base. On the surface of the cone we will get the shape of circle. So this is what I'm doing over here. I'm using here one cutting plane. This is what we can say, cutting plane. We need to cut the cone in such a way that this cutting plane should be parallel to whom, dear? Should be parallel to base of a cone. Then what we will get? We will get the shape of a circle. Clear? Again, question will be arise. So what is the application of a circle? Application of a circle. In the exam, how we'll write the regarding the circle? We need to cut the cone in such a way that the cutting plane should be parallel to base. On the surface we will get the shape of circle. And application we know very well. Clear? So it is widely used in a disc. I think so you guys is watching the movie, is it right? Then you are using the players, CD players and DVD players. The shape is how it is there. It should be looking like a circle. Clear? The shape is how it is there. The shape is looking like a circle. And then where we are using in ring. Okay, ring. If you observe over here, the shape is how it is there. The shape is, it is looking like a circle. And third, we are using in the plates. The plates also looking like a circle. Clear? And then we are using the wheels. The wheel maybe it may be two-wheeler wheel or four-wheeler wheel. Is it right? The shape is how it is there. It should be looking like a circle. It should be looking like a circle. And then gears. So they having the different types of gear like spur gear, helical gear, bevel gear, worm gear. The different types of the gear. The shape is how it is there. It should be looking like a circle. Clear? And then we know that pipes. Clear? If you cut to the, let us see, this is the pipe. Assume over here, this is the pipe. If you cut to the pipe, the shape is how it is there. It should be looking like a circle. The inside should be looking like a halo, or the outside should be looking like a circle. Clear? That. If you observe the cap, okay, cap also looking like a circle. So we can write here, pipes also looking like a circle and cap also looking like a circle. And bearing, clear? Bearing also looking like a circle. Like this, bearing will be there. Okay, it should be looking like a circle. Clear? Then next topic. ellipse. Then let us see. First of all, we need to draw the shape of a cone. Okay, let us see. We need to cut the cone in such a way that the cutting plane should not be parallel to base of a circle. Should not be parallel to base of a circle, and should not be parallel to altitude, and should not be parallel to slant edge. Then let us see this shape. This is the cutting plane. Okay, I am representing over here cutting plane. This cutting plane, it is not parallel to base, not parallel to slant edge, not parallel to altitude line. Then what will be appear on the surface of the cone? Ellipse will appear. Clear? So this is, we have to show here ellipse. Again questions will be arise, what is the eccentricity of the ellipse? So we know the formula of the ellipse. It's a ratio of distance of a point from the focus by distance of a point of a circle. You studied in the 10th and 12th standard. The same thing we need to recall here. Distance of a point from focus by distance of a point from its directrix. The eccentricity, the ratio is given 2 by 3. So 2 by 3 we can say that if the value, if it is a lesser than 1, 2 by 3 if you divide, then you will get the value here less than 1. So how much you get? 2 by 3, 0 0.6. 0 0.3 should be lesser than 1. If eccentricity, if the lesser than 1, so what we can say? We can say as ellipse. Okay. Always remember, in the exam or in the viva he will ask. So if eccentricity, if less than 1 is called as, what we can say? We can say as ellipse. Clear? Again, one more question will be asked. What is the application of an ellipse? Okay, let us see. So we know very well we are using the different applications of ellipse will be there. For example, in the astronomy, first one is the astronomy. Astronomy, we can say that all planet will move around the sun in the elliptical orbit. How it will be there? Let us see. All planets revolve around the sun, in a elliptical shape or in an elliptical orbit, we can say that. Let us see. This is a sun. Around who is revolving here? Revolving all planets. The shape is, how it is there? The shape is elliptical in shape will be there. Is it right? Done. Second one. It is visible. Oh. Okay. Right now it is set. Then third one, parabola. Again, I will write these applications of this ellipse. The elliptical shapes are used in the arcs, domes, and ditches we are using. So you can write. So the shape of arcs should be in the elliptical shape. The domes should be in the elliptical shapes. Are you observe this radome dome shape? How it is there? It should be looking like elliptical shape. Is it right? Another one, which one is there? Bridges should be looking like a elliptical shapes. Is it right? And elliptical cams will be there. Elliptical cams should be in the elliptical shape. We know very well. Another one we can say over here. The revolve of the electrons. Is it right? The all planets will be revolve around this cell. And moment of electrons also elliptical shapes. The moment of electrons around the nucleus, it's visible. Okay, around the nucleus. In a elliptical shape. Clear? This is the application of an ellipse. Next one is parabola. We need to cut the cone in such a way that this cutting cone, it is a parallel to this slant edge. Then how to cut this cone? Let us see. We need to cut the cone in such a way that this cutting cone always parallel to whom dear? Parallel to slant edge. Slant edge. Then what will be appear on the surface of the cone? We will get the shape of parabola. It's not cut properly. Okay, then the shape is how it is there? Parabola. Again, I will draw the image properly. Let us see. We need to cut this cone in such a way that the cutting cone should be parallel to slant edge. On the surface of the cone, the parabola will appear. Clear? This is the parabola. It's a parallel to whom? It's a parallel to slant edge. Parallel to slant edge. So in the exam, if they ask about how you will get the shape of parabola, then you have to give the answer in such a way that this cutting plane, the cutting plane, it is a parallel to whom dear? It's parallel to slant edge. On the surface of the cone, the parabola will appear. Clear? Again, the questions will be arise. What is the eccentricity of a parabola? Always remember the eccentricity of a parabola, it should be 1. Then how will we get the 1? Let us see. If the distance of a point from the focus, if it is given here 50 mm, then we can divide 25 mm by 25 mm. Then how much will you get here? If we cancel both, because the distance of a point from the focus should be 25, the distance of a point from the directrix should be 25. If we cancel both, then we will get the value here 1 mm. So will we get the value here 1, not mm, because this mm already is cancelled over here. Clear? The eccentricity of a parabola is always equal to 1. Then again, what is the application of, again the questions will arise, what is the applications of a parabola? Okay, so we know that the application of the parabola, which is widely used in a Golden Gate Bridge. The Golden Gate Bridge, that should be looking like a parabola. And then second one, we are using in a Howrah Bridge. Howrah Bridge. And third one, we are using in a parabolic mirror. The parabolic mirror, if you observe over here, the shape is as it is there, it should be looking like a parabola. Okay, and then antenna, it should be looking like a parabola, we know very well. And then the solar furnace or solar cooker should be looking like a parabola shape. Solar furnace and solar cooker, the shape is parabola. Again, you can give the example. If a ball is thrown in upward direction, then they move in a projectile motions. So under the gravity, is it right? So the shape is how it is there, is in parabola. Is it visible properly? Okay. Then, so you can write a ball thrown in a upward direction in the form of parabola path under gravity. Is it right? Under gravity. Let us see. If you are throwing a ball like this, they form as the projectile motion. The shape is already is there. The shape is in the form of parabola. Clear? Next one is hyperbola. We need to cut the cone in such a way that this cutting cone, it is a parallel to altitude. We will get the shape of hyperbola. Again, I will recall altitude. We need to cut the cone in such a way that this cutting plane is parallel to whom, dear? Parallel to altitude. What will appear on the surface of the cone? Hyperbola will appear on the surface of the cone. Clear? Then again the question will arise, what is the application of a hyperbola? So we know very well they are having the different applications of a hyperbola, like, so you can say that First one is the lamp shadow. So in the modern lamp, shadow should be looking like a hyperbola shape. Is it right? Let us see. This is my hand. My shadow will appear like this. Is it right? This is the shadow. The same lamp shadow will appear on the vertical wall. Is it right? The shape is how it is there. The shape is in the form of hyperbola. And second thing is cooling tower. In the cooling tower, we know that the shape of the cooling tower in a power plant is in hyperbola, because this shape will provide the high strength and high stability with a less construction material we are required for making the cooling tower. For that purpose, we are giving the more priority for the hyperbola. And then third one is the navigation system. We are using in a navigation system. So this hyperbola used in a radio navigation system. The position of ship and aircraft can be determined by using of hyperbola curve formed by the signal from one station to the another station. So for that purpose, we are using the hyperbola. These are the applications of the hyperbola. Thank you. I hope so no one is having that doubt regarding up to this sessions. Just I will recall once again the conic section, in which we need to cut the cone. How will we get the different section? Like we will get the shape of circle, we will get the shape of ellipse, we will get the shape of parabola, we will get the shape of hyperbola. So we know that the topmost part of the cone is known as apex, and the bottommost part of the cone is known as base of a circle. The right hand side, the left hand side and the right hand side of the line is known as slant edge. Okay, the all inside line is called as called as generator line. The center line is called as altitude or axis. Then first thing is circle. We need to cut the cone in such a way that this cutting plane is parallel to wound ear, parallel to base. Then what will be appear on the surface of the cone? Circle will appear. It is having the different application we are using in the CD players or DVD players. The CD or DVD player, the shape is how it is there. It should be looking like a circle. Ring, this ring, the shape is how it is there. It should be looking like a circle. And the plates, is it right? We are whatever we eating the food, is it right? The shape is how it is there. The shape is circle, is it right? The wheels, two-wheeler wheels, four-wheeler wheels, the shape is how it is there. It should be looking like a circles. Okay, and the gears like the spur gear, helical gear, bevel gear and worm gear, they should be looking like a circles. Pipes, the pipe, if you let us see, let us think about it. This is the pipe. Okay, the pipe shape should be looking like a circle, is it right? Let's think about, this is the pipe. Okay, the pipe should be looking like a circle. And then cap, the cap, it should be looking like, how's it here? It should be looking like a circle. And the bearing, okay, the bearing also looking like a circle. These are the application of a circle. Second one is the ellipse. Okay, so ellipse, we know that we need to cut the cone in such a way that this cutting plane, let us see, this cutting plane, it should be parallel to wound ear, should not be parallel to anyone, should not be parallel to base, it should not be parallel to slant edge, it should not be parallel to altitude. Then what will be appear on the surface of the cone? Ellipse will appear. Then again the question will be arise, what is the eccentricity of the ellipse? So you have to tell that the eccentricity of the ellipse is lesser than 1. And what are the applications of the ellipse? So we know that all planets revolve around the suns, is it right, in an elliptical orbit. Meanwhile, electrons also revolve around the nucleus in the form of elliptical order. And arcs, okay, domes and bridges, so the shape is how it is there. The shape is in elliptical shape. How it is there? Elliptical shape. Is visible properly? Okay. Then moment of electrons around the nucleus in a elliptical shape. Then next one is parabola. Let us see parabola. Then we need to cut the cone in such a way that this cutting plane, it's visible. Okay, this cutting plane is, okay, let us see. Cutting plane, it is a parallel to wound here, it's a parallel to slant edge. What will be appear on the surface of the cone? The parabola will appear on the surface of cone. The eccentricity of a parabola is equal to 1. Clear? And then what is the application of the parabola here? So we know that they having the different application of the parabola. So we are using in the Golden Gate Bridge, is it right? In the Howrah Bridge will be there, in parabolic mirror will be there, should be looking like a the parabola shapes. The antenna should be looking like a parabola shape. Solar furnace will be there, solar cookers will be there. So these are the applications of a parabola. And next one is, which one is there? Hyperbola. Okay, so we need to cut the cone in such a way that the cutting plane should be parallel to wound here, it is a parallel to altitude. What will be appear on the surface of the cone? So it will be appear as a hyperbola. Clear? Then so again one more thing will be there, eccentricity. The eccentricity of the parabola is greater than 1, and ratio of the parabola is, how it is there? 3/2. Clear? The eccentricity of a hyperbola is greater than 1 and ratio should be 3/2. The application is, so it is widely used of a hyperbola, lamp shadow. The lamp shadow, if you are using the modern lamp, the shadow will appear where here, it should be appear on the vertical wall. The shape is, how it is there? The shape is hyperbola. Second one is the cooling tower. The cooling tower, the shape is, how it is there? The shape is hyperbola. Another one is the navigation system. The shape is, how it is there? It should be shape of hyperbola. I hope so no one is having that doubt regarding up to these sessions. So in the next sections we are going to discuss the problems on a ellipse. Is it right? Thank you.